In the previous lessons, we have seen several different kinds of authentication schemes. We started with basic authentication, then we looked at how we can use cookies for doing authentication and even signed cookies, and thereafter we looked at session-based authentication, where the server is keeping track of information about each client, and then the cookie will be used as a way of indexing into the server-side database to extract additional information to validate the user. Now, the cookie and session-based authentications are not scalable because the server needs to keep track of all the different users. Even though this is done outside the HTTP protocol itself, but still, the fact that you need to keep track of all this session information on the server side makes it not very scalable. So this is where token-based authentication has proved to be very useful. We'll look at token-based authentication in a little more detail in this lecture and the exercise that follows. Again, quickly reviewing cookies and session-based authentication. With cookie-based authentication, we notice that cookies are stored on the client side and the cookies are included in every outgoing request message, whereby the server is reminded about the specific client by extracting information from the cookie. Cookie can be used together with sessions, whereby the cookie stores the session ID, and then when the server receives the incoming request from the cookie, it extracts the session ID and then uses that as an index into the server-side session store to retrieve the session information for that particular client. Now, this approach, as I said, is not very scalable because if you have thousands of sessions, the server needs to keep track of all these thousands of sessions on the server side. Even though it is done independent of HTTP in a store, either a file store or a database. But still, the fact that you need to track all this information makes it not scalable. So, again, to remind you one more time, why do we talk about token-based authentication? Session-based authentication, as we have seen earlier, works perfectly fine for web applications and can easily take care of user authentication. But then, session-based authentication violates the principle of stateless servers and also leads to scalability problems. The second issue is mobile applications do not handle session-based authentications very well. Similarly, mobile applications have a hard time dealing with cookies. So, in such circumstances where your server is serving data for both a web application as well as a mobile app, then the session-based authentication will not be very useful. And this is where token-based authentication becomes a lot more easy to use. In a token-based authentication, as the name implies, the server will issue a token to a validated user, and all subsequent requests coming from the client side will bear the token in the request itself, either in the form of a request header or in the body of the request message. Furthermore, token-based authentication also helps us to deal with what are called as CORS or CSRF problems, cross-origin resource sharing problems, and so on. I'll briefly talk about CORS in the next module, but for the moment, token-based authentication addresses some of the issues that arise with CORS and cross-site request forgery related issues. Not only that, token-based authentication is a lot more easy for one application to share its authentication with another application. Of course, this is all done in a secure manner, but with session-based authentication, that is not straightforward. How does token-based authentication work? In token-based authentication, the user first needs to validate himself or herself on the server side. Now, this validation could take on the forms that we have seen earlier. So we can use a local validation using username and password, or we can even use third-party validation using technologies like OAuth or OAuth 2.0 or OpenID. We will talk briefly about OAuth and OAuth 2.0 in the next module. But no matter which way the user authenticates, once the user is authenticated, thereafter your server can simply issue a token to the user, and all subsequent communication between the user and the server can be done simply using this token. JSON Web Token that we will talk about is one such token-based authentication scheme. And the server, when it creates this token, will create a signed token using a secret on the server side, which only the server knows. So thereby, even if a third party intrudes in between and tries to manipulate the token, even if it captures the token and tries to manipulate the token will become invalid. And so that way of protecting the user is easily feasible. All subsequent requests from the client side should carry the token in the request, either, as I said, in the header or in the body of the request message. So when the server receives this token, the server will verify the token to ensure that this is a valid token. And then if it is a valid token, the server will then respond to the incoming request. As I mentioned, JSON Web Tokens is one such token-based authentication scheme. JSON Web Token is a very simple way of encoding information in a token and then pass it to the client side. JSON Web Token itself is based on standards. This is based on the IETF RFC 7519. IETF here stands for the Internet Engineering Task Force, the organization that mandates everything about how the internet works and deals with the protocols and the policies related to the internet. The RFC stands for the standards document. In IETF terms, RFC stands for request for comments, and each such standards document carries a number. 7519 in this case refers to the document, the standards document related to JSON Web Token. The JSON Web Token itself is a self-contained token. It carries all the information within itself that is necessary to identify the user. Not only that, a JSON Web Token can be shared between two applications. So for example, one application, when it authenticates and then gets hold of a JSON Web Token, can pass that JSON Web Token to another application that it is willing to authorize to access the server on its behalf. This sharing of the token is done in a very secure manner, so don't worry too much about security in there. This is done in a secure manner whereby the sharing of the token between one application to another, whereby the authorization is transferred over to a second application, and the second application can be authorized on behalf of the first application to communicate with the server. This is feasible with tokens. Now, of course, the engineer in you will obviously be wondering what exactly is inside a JSON Web Token and how is it useful. The JSON Web Token, as I said, is encoded into a long string, and this string itself can be interpreted as consisting of three parts. The string itself, or the encoded string itself, contains three parts: the header, the payload, and the signature that carries enough information about how this token is encoded. The header itself contains the specific algorithm that is used for encoding this JSON Web Token and the type of the token itself. The algorithm in this case would be HS256, which is a 256-bit encoding scheme that is used for the hashing the information inside of the token. And in this case, this happens to be the JSON Web Token, and so the type field will be set to JWT. And so that is the information that is stored in the header of the JSON Web Token. The payload itself carries information that helps you to identify the user. In the exercise that we will do, our payload will carry only the ID of the user inside the payload. No other information is necessary. This ID can be used on the server side to index into the MongoDB to retrieve the full user information if required. So you will see that we will be encoding the ID and then storing it in the payload of the message. You can store additional information in the payload of the message if you require, but the more information that you store there, the larger the corresponding JSON Web Token is going to be. So try to limit the amount of information that you store in the payload of the JSON Web Token. As we will see in the exercise, we have a node module that enables us to encode and create a JSON Web Token based on the information that we want to put in the payload. Now, when you create the JSON Web Token, you also supply a signature, a secret key on the server side, which is used for encoding this JSON Web Token. And that secret is also included in the signature part of the JSON Web Token. The signature itself is included in such a way that there is a base64 encoded header and payload, which is then encoded using the specific secret that is used by the server. And this is encoded in, as I said, the HMAC that we have referred to in one of the previous lessons, and using the 256-bit hashing, and that is included in the signature. So when this JSON Web Token is received on the server side, and when the server decodes this token, then the server is able to cross-check to make sure that this JSON Web Token has not been tampered by anybody while the token is being passed between the client and the server side. So if you know anything about security and intruders and so on, you understand why it is important to encode the token and verify the authenticity of the token on the server side. As I mentioned, if you need to deal with JSON Web Tokens in your node application, there is a specific node module called as the JSON Web Token node module. This node module implements the JSON Web Token related standards, and it can be included into your node application. This module itself provides a method called sign, which allows you to sign and issue the token to the client from the server side. It also contains a verify method, which can be used to verify the authenticity or to ensure the authenticity of the incoming JSON Web Token. So we will be making use of the JSON Web Token module in our exercise. Together with the JSON Web Token module, we also use the Passport JWT module, node module, which provides the JWT-based strategies for our Passport authentication module. So this provides a Passport strategy for authenticating using JSON Web Token. So this allows you to authenticate RESTful endpoints using the JWT as the method for doing the validation without requiring the server to use sessions. Now, the JWT Passport module supports a method of even extracting the JWT token from the incoming request message and then even verifying the token on your behalf. The Passport JWT module in turn uses the JSON Web Token module for doing the verification of the JSON Web Token. The token itself can be carried in the header of the incoming request, in the header, even in the authentication header of the incoming request, which is what we will be doing in the exercise. The token can be also carried in the body of the incoming request, in which case we have to extract the token from the body of the incoming request and then make use of it. The Passport JWT module supports that also if you choose to use that as a way of passing the token back from the client to the server side. The JSON Web Token can be also included in the URL query parameters if you so choose to, and can be extracted from there by Passport JWT and used for authentication. Now, with this quick understanding of JSON Web Tokens and how they are useful, we will move on to the exercise where we will use the Passport JWT module together with the JSON Web Token module and configure our Express REST API server to use JSON Web Tokens.